Let's look at section 7.2, number 6. It says a data set includes 103 body temperatures of healthy adult humans having a mean of 98.9 degrees Fahrenheit and a standard deviation of 0.67 degrees Fahrenheit. First, we're going to construct a 99% confidence interval estimate of the mean body temperature of all healthy humans. So the first thing I notice is that they've collected 103 body temperatures. So that's my sample. My N is 103. My mean is from the sample, so its X bar is 98.9. And my standard deviation is sample standard deviation. It's not population standard deviation, so it's 0.67. So since this is giving me sample information instead of population information, that means I'm going to use the student T distribution as long as it meets the requirements. So I'll be finding T alpha divided by 2. And since my N is greater than 30, I can use the T alpha. So the first thing I need to do is find that value. So my confidence level is 99%. So I've got a 99%, so 0.99 is my area centered in the middle. So my alpha needs to be split in 2. So if that's 0.99, my alpha would be 0.01. When I divide that by 2, I get 0.005 and 0.005. So that's the area in the two tails. So to find the T alpha divided by 2, I can use my calculator or my StatCrunch. Let's use the calculator this time. Maybe not, my calculator's not working. So let's go to StatCrunch. You're going to do stat, calculators, T, degrees of freedom is N-1. So my N was 103, so I'm going to use 102. I'm going to change this to 0.005 and change my inequality to greater than or equal to. So my T alpha that I need to use is going to be 2.62. So that's the number for T alpha divided by 2 that I'm going to have to use in my formula. Now if you go to your formula sheet, we're using this box right here, constructing a confidence interval. We found our T alpha divided by 2. Now we need to use this formula to find our error, and then to find our lower bound and our upper bound, you are going to add the error and subtract the error to find the lower bound and the upper bound. So first we're going to find the error. We had 2.62 times your standard deviation, which in this case was 0.67, and then divided by the square root of N, so the square root of 103. You're going to punch that in your calculator. We're going to have 2.62 times 0.67 divided by the square root of 103. Which is going to give us 0.173. So that's my error, that's my margin of error. So what I'm going to do is I'm going to take my mean and subtract that and add that to get the lower bound and the upper bound. So my lower bound will be 98.9 minus 0.173, and my upper bound will be 98.9 plus 0.173. So 98.73 and 99.07. That's going to be your lower bound and your upper bound. So I entered my answers. I had to go back and add one more decimal place because they wanted 3 decimal places, but that wasn't much more work. So that gave me 98.727 as my lower bound and 99.073 as my upper bound. I'll let you guys do the what does this suggest about the use of 98.6 as the mean body temperature.